Okay, all right, guys. Last time we were looking at the dot product, which is just one way of multiplying vectors, but yet there's also another method of multiplying vectors, which is called the cross product. Cross product is kind of different, and therefore I kind of beg your attention in terms of exactly how we perform the cross product. Okay. To introduce the cross product, I'll start by introducing the right hand rule, and this is the kind of rule that we introduce especially when we're looking at torques moments when we're looking at physics. Okay, so we start here. So if you get your right hand and fold it like this, and point your right thumb up, and then let's say we have a plane, which may be a table, and then on that plane we have two vectors. So we have one vector u, which is pointing in that direction, as you can see there. That's our vector u. Then we have another vector v, and let's say just for argument's sake that the angle between the two vectors is theta. So we can define another vector which is called n. So we can define another vector which is called n, and this vector n is going to be perpendicular to both vectors. So it's perpendicular to u, and it's also perpendicular to u, and it's also perpendicular to v. But we can just say it's perpendicular to the plane which contains vector v and vector u. So when we do that cross product, so if we do the product between the two vectors u, now this time around the product we're talking about is a cross product. So we're no longer using a dot to represent the product. Now we're using. So now, if we can get such a vector such that it's perpendicular to both u and v, and is pointing that particular direction according to the right hand rule, then what we have is the cross product of the two vectors. So that's basically actually how we define the cross product. So this is very important to know. So if you wanted to know, so here we're talking about when we say u cross v, this is how we take it, especially when we're looking at the folded fingers. So what you can see here is that as you can see here, we are moving. The fingers are moving in the direction from u to v. So they are in that direction, as you can see there. In that direction, they're moving from u to v. So that's why it's called u cross v, and the resulting vector will be in the direction of the thumb. So that's what we have there. So that will be the resultant vector n. So this should tell us that then v cross u, it will not be equal to v u cross v, basically because then this time around probably the finger that thumb will point downward. Okay, just to give it a more formal definition. So the cross product of two vectors, u and v, so we normally read that as u cross v, unlike the way we are reading for dot product, we're saying u dot v. So u cross v is the vector. So u cross v, u cross v is the vector that you get the magnitude of u, and you also get the magnitude of v, and then you multiply by sine of the angle between the two vectors. So remember, for cross product we were taking the cosine of the cosine of the angle between the two vectors. But remember, the dot product, the answer was a scalar quantity, but this time around with vector product, the answer is, or cross product, the answer is another vector. So we have this will be more like the magnitude of the vector u cross v, then we multiply that by direction. This particular case will multiply it by some unit vector n. So we are just, so we use this n, so we just put a hat to mean that we are talking about the unit vector. So that is what we have when we are defining the cross product. So that's what we have. So another concept, remember, when we are looking at dot product, we say that if two vectors are perpendicular, then their dot product is what? Their dot product is 0. This time around, since cross product kinds of seems like the opposite to dot product, then we can see that actually this time around, instead of talking about perpendicular, now we'll be talking about parallel vectors. So if you've got two non-zero parallel vectors u and v, which are parallel, so they are only parallel if u cross v is equals to 0. So which means if you're told to check if two vectors are parallel, then you just get their cross product, and if their cross product is 0, then what you get is if you get 0, then what you have are parallel vectors. So that is some theorem that we can use. Okay, so maybe just to look at a few properties of the cross product. So let's say we have three vectors. We have u, we have v, and we also have w. And then let's say we have r and s, which we are going to treat as scalar quantities. So we can have the following properties. So we have the first property, which says that if you get the scalar quantity, that scalar r, and then you multiply it to the vector, and you also get that scalar quantity s, you multiply it to another vector v, and then you get the cross product, provided you're still keeping the same sequence from u cross v. So you can just get u cross v. You can multiply the scalar quantities first and then multiply to the cross product of the two guys. Then the second property is saying that if we have I want to take the cross product of a vector cross a sum of two vectors, you can first of all you can distribute. So you can start by getting the cross product of u and the other one. Then you also get the cross product of u and w. Then you just add them. So you can distribute. And then the third one is telling us this is the one by the right hand rule. V cross u is not equal to u cross v. It's not commutative, but rather v cross u is equal to the negative of u cross v. So that's the third property. Then the fourth property is also a distributive law in the opposite direction. So if you have v plus w cross u, so since by this property, then therefore we can't interchange this, so it's still going to be v cross u. Then we can also do w cross u. Then we add the two quantities. So that is also another distributive law there. Then if you have a 0 vector and then you cross it to any vector, the answer will be 0. Okay. Then 6. If we have we first of all take the cross product between v and w. Then after that, then we get the cross product of u. It's not associative, as you can see. It's not associative. So actually, the only equivalent is that you can actually first of all get the dot product. So you get the dot product between u and w, then v, and then minus u dot v cross w. So you can just swap them like that. So that is what we have. Maybe just some general remarks on these properties. So what we have here is that if you have v cross u, now you're now moving like this, like in the direction of the hand. So now you of course now it will point downwards to fill the table. So it's now pointing direction downward. So that's why we have negative. So that's why we have that negative there. Okay, by the right hand rule. Okay, going back to unit vectors. So if we have unit vectors in the xy, in the space in the xy z, so we have the I pointing in the xj, that z. So what we need to know is that by the right hand rule, if I move I cross j, the thumb will point up, so that's k. Then if I move from k, so if I move from if I want to get, for example, if I move from j cross k, the hand will point this direction, then I get my I. Then if I move if I want to move, let's say from I want to move from k cross I, then I move from k going this side around, then the right hand will point that way. So actually k is just I cross j, j is just k cross I. So we have all these properties. So the simplest way you can easily remember this, so we have our I, then you can put your j like this, so you can go anti-clockwise, then you have your k somewhere there. Okay, so you move like this. So this is how you move. If you move in the opposite direction, then it's a negative. So I cross j, you get a k. J cross k, you get an I. k cross I, you get a j. But if you move in the opposite direction, like if you want to say k cross j, you get negative I. I cross k, you get negative j. So that is what you have. And then by the virtue of being parallel, so if you I and I are parallel, so I cross I, j cross j, k cross k, that you get 0. Okay, I think we are done for this section. See you in the next section.